Lesson 3.5, Moment of Inertia. Torque is R times the force that's tangential, and the tangential force is mass times the tangential acceleration, because force equals mass times acceleration. So torque is R times the mass times the tangential acceleration. But wait, tangential acceleration is just R times angular acceleration. So put that in. So torque is mr squared alpha. We call this mr squared I, which is the moment of inertia of a particle. So our torque formula becomes torque equals IA, which is very similar to F equals ma. We have an acceleration, we have linear, and we have angular. So linear acceleration, we have linear force equals mass times linear acceleration. And then we have torque, which is one of the things like a force that makes things want to move in a circle. And then the I, the moment of inertia, is like the mass. Both mass and moment of inertia are measurements of inertia. And then we have angular acceleration. So this is Newton's second law for rotation. Just remember, your angular acceleration must be in radians per second. The moment of inertia, I, measures how much an object wants to keep rotating, or if it stopped, not start rotating. So it really just measures the angular inertia. So it's a measure of inertia, but for rotation. If it's not a point, then we have to use calculus, because the mass is spread out all over kinds different areas. So we use calculus, and we add up the moment of inertia for all the little particles in our mass distribution. And we see some results here. So we have hoops. A hoop has no thickness. If there is thickness, then it's an annular cylinder or ring. And you see these other things. You have a solid sphere, which means the mass is all in the middle, or a spherical shell, which is hollow on the inside. Anyway, their units would be kilogram, and then our radius would be in meters. So our unit would be a kilogram meter squared. The St. Joseph River Swing Bridge in St. Joseph, Michigan has a mass of 300 tons, or 2.72 times 10 to the 5th kilograms, and is 231 feet long, or 70.4 meters. If the motor produces 563 kilonewton meters of torque and takes 10 seconds to accelerate the bridge to 0.05 radians per second, what is the bridge's moment of inertia? Well, the first thing you probably want to do is go back and say, oh, hey, which one of these formulas fits that swing bridge? But it's not a nice mass distribution, like it's not a cylinder or a rod or something like that. So maybe we can use our torque and figure it out. So let's see. If we have torque equals I alpha, and I'm looking for the I need to know alpha. Alpha is our change in angular speed over time. So it takes time to accelerate to 0.05 radians per second from nothing. And that was 10 seconds. So our angular acceleration is 0.005 radians per second squared. So I can fill that in for the alpha. Oh, for the torque, I know the torque is 563 kilos, so that's times 10 to the 3 Newton meters. And then we divide, and I think we'll get 1.13 times 10 to the 8 kilogram meter squared for the I. Just an interest, it's very well balanced. This 231-foot, 300-ton bridge can be turned with a single 10 horsepower electric motor and takes about 42 seconds to open. A spinning ride at a carnival is accelerating at 4 radians per second squared. Now, we know alpha. If the ride is shaped like a hoop and a motor is exerting, we know our torque, 128,000 Newton meters of torque. What is the radius of the 500 kilograms? We know our mass is 500 kilogram ride. All right. Well, it's a hoop, and let's say it's one of those rides where you kind of get squashed up against the side, and it's spinning about its axis. So I have torque, I, alpha, and our I in this case is mr squared, which is a hoop rotating around its central axis. And that was from the table with all the different shapes and their moments of inertia. I don't know the R, so I'm going to start with the torque formula. And I'm going to find the moment of inertia. So divide by 4, and we end up with 32,000 kilogram meter squared. But that is mr squared. And our mass is 500 kilograms. So divide by the 500, and we get 64 meters squared equals the r squared. Take a square root, and you'll see that the radius is 8 meters.